Students, this is NCERT exercise problem 2.47 from page number 71 of structure of atom, right? So let's read the statement. Neon gas is generally used in the signboards if it emits strongly at 616 nanometer. Calculate the frequency of emission, distance traveled by this radiation in 30 seconds, energy of quantum and number of quanta present if it produces 2 joule of energy, right? So in this question, they have given you a neon gas which is generally used in signboards, right? It is emitting energy at the wavelength of 616 nanometer, right? In this question, first of all, you have to find the frequency of emission. Second, distance traveled by this radiation in 30 seconds and energy of one quantum. Here they are asking you to find the energy of one photon, right? And last one is number of quanta present if it produce 2 joule of energy. Now in this question, if we are having 2 joule of energy, in this 2 joule of energy, how many quantas are present? That means how many photons are present? You have to find that, right? So for this, first of all, we'll see the given values, right? So in this question, we are having wavelength. Now wavelength is denoted by lambda and it is 616 nanometer, right? Now first of all, we'll find frequency of emission, right? So for frequency, we'll see the relation, right? Frequency is denoted by nu and it is given by C by lambda, right? Now here lambda is wavelength and C is velocity of light, right? So velocity of light you have to remember this value. It is 3 into 10 raised to power 8 meter per second. Now if you see, we are having velocity of light in meter but wavelength in nanometer. For easy calculations, we'll just convert this nanometer into meter, right? So I'll write over here 1 nanometer equal to 10 raised to power minus 9 meter. Now simply write over here 616 into 10 raised to power minus 9 and it is converted into meter, right? Now simply put the values. So nu equal to C, that is 3 into 10 raised to power 8 meter per second divided by lambda. Lambda is 616 into 10 raised to power minus 9 meter, right? Now I'll cancel meter with this. If you see, this 3 is less than 616, right? So it will be complicated during the division, right? So what I'll do, I'll simply make this value higher than 616, right? So for this, I can write 10 raised to power 8 as 10 raised to power 5 plus 3. If we are having powers in addition, this means these powers are in multiplication. So it will be 10 raised to power 5 into 10 raised to power 3, right? This 10 raised to power 3 can be written as 1000. This 10 raised to power 8 will be 1000 into 10 raised to power 5. Simply displace this value. So nu equal to 3 into 1000 into 10 raised to power 5 and it will be divided by 616 into 10 raised to power minus 9. Unit we are having second inverse only. 3 into 1000, it will be 3000 into 10 raised to power 5. Now this 10 raised to power minus 9 is negative in denominator. When I'll take this power in numerator, it will change its sign, right? So it will be 10 raised to power 9 divided by 616 and unit I am having second inverse only. So 3000 divided by 616, it will be 4.87 into these two powers are in multiplication. So you can simply add them 10 raised to power 5 plus 9 and units will be second inverse, right? So nu equal to 4.87 into 10 raised to power 5 plus 9. It will be 10 raised to power 14 second inverse. Now I know that 1 hertz equal to 1 second inverse. So I can simply replace second inverse with hertz. So frequency of this radiation will be 4.87 into 10 raised to power 14 hertz, right? Now we will see the B part of this question. in B part, they are asking you have to find the distance traveled by the radiation in 30 seconds. Simply, I know that distance equal to speed into time, right? Now, here this radiation is having speed equal to velocity of light, right? So, you can write over here speed equal to velocity of light, and it is 3 into 10 raised to power 8 meter per second. Now time is 30 second, right? Simply put the values. So distance traveled by this radiation equal to speed 3 into 10 raised to power 8 meter per second into time 30 seconds. So I'll cancel this second with second inverse. So 3 into 30, it will be 90 into 10 raised to power 8, and units I'm having meter only, right? This 90 can be written as 9 into 10. Now this 10 raised to power 8 will be mentioned with 8. Now this 10 means it is 10 raised to power 1, right? These two powers are in multiplication, so you can simply add them. So 9 into 10 raised to power 1 plus 8 unit meter only. So 9 into 10 raised to power 9 meter is the distance of this radiation that is covered in 30 seconds, right? Now let's see the third problem. In C part, you have to find the energy of quantum. Now quantum means we have to find the energy of one photon, right? We will use the formula. You can write over here energy of quantum. It is denoted by E and expressed as h nu. Now h is Planck's constant, and you have to remember this value 6.626 into 10 raised to power minus 34 joule second. Frequency we have 4.87 into 10 raised to power 14 second inverse. Simply put the values. So E equal to h 6.626 into 10 raised to power minus 34 joule second into frequency 4.87 into 10 raised to power 14 second inverse. I'll cancel second with second inverse. Now when you'll multiply 6.626 with 4.87, it will be 32.268. These two powers are in multiplication, so you can simply add them. 10 raised to power minus 34 plus 14 units I am having joule only. So E equal to 32.268 into 10 raised to power minus 34 plus 14, it will be 10 raised to power minus 20 joule. Now I just want to convert this 32.268 according to the scientific notation. According to the scientific notation, there should be only one digit on the left side of the decimal. I'll simply displace this decimal from right to left. So if I am displacing decimal from right to left, power will be positive. So the answer will be 3.2268. I am displacing decimal up to one digit, so it will be 10 raised to power 1 into 10 raised to power minus 20 joule. These two powers are in multiplication, so you can simply add them. So energy of quantum will be 3.2268 into 10 raised to power 1 minus 20, and we will mention unit over here. So E equal to 3.2268 into 10 raised to power minus 19 joule. We will see the D part of this question, right? So in D part, we have to find the number of quanta. That means number of photons present which produce 2 joule of energy. In this part, we will apply unitary method. For unitary method, we'll see the energy of one quantum that we found in C part. We can write over here 3.22 2.68 into 10 raised to power minus 19 joule of energy is produced by quanta, or you can write quantum over here, right? It is 1. And 2 joule energy is produced by quanta. Now we'll mention plural of quantum over here. So the value on right side we will mention in numerator. The first value on left side will mention in denominator 3.2268 into 10 raised to power minus 19 joule into second value on the left side. So I'll cancel joule with joule. So if you see 1 into 2, it will be 2. 10 raised to power minus 19. When I'll take this value in numerator, it will change its sign. So it will be 10 raised to power 19 divided by 3.2268. And here units are quanta only, right? So 2 divided by 3.2268, it will be 0.619 into 10 raised to power 19 quanta. Now I just want to convert this 0.619 according to the scientific notation. So according to the scientific notation, there should be one non-zero digit on the left side of the decimal. So what I'll do, I'll simply displace this decimal up to one digit from left to right, right? So power will be negative. So 6.19 into 10 raised to power minus 1, because I am displacing decimal up to one digit only, right? Into 10 raised to power 19 quanta. These two powers are in multiplication, so simply add them. 6.19 into 10 raised to power minus 1 plus 19 units quanta. So 2 joule of energy is produced by 6.19 into 10 raised to power minus 1 plus 19. It will be 10 raised to power 18 quantas.